Hi everyone, welcome back to my channel. Today's video we will continue with the start of private network. This tutorial illustrates how can start a small standalone blockchain network with authority set of private validators. All blockchains require the nodes in the network to agree on the set messages and their order to successfully create blocks and progress from one block to the next. Each block represents the state of data at a specified point in time, and the node's agreement on the state is called consensus. There are several different algorithms used to reach consensus, including the following. Proof of work consensus depends on the computational work done by validator nodes to add the valid networks to the chain. Proof of stake consensus select the validators to add the valid blocks to the chain based on the cryptocurrency holdings that they have locked up as a stake in the network. Proof of authority consensus relies on the set of approved account identities to act as validators. The nodes associated with the approved accounts have the authority to put transactions into blocks. The subtree node template uses the proof of authority consensus model, also referred to as authority route or Aura consensus. Now, the Aura consensus protocol limits block production to voting list of the authority realized accounts authorities that create blocks in the route robin function. Now in this tutorial you will see how this consensus model works in the practice. First, by using the predefined accounts that are part of the node template, then by adding a new authority to the approved set. Before you begin, verify the following. You have to configure your environment for software development by installing Rust and Rust2 Chain. And you need to have create your first software blockchain and have a software node template installed locally. And unless you are generally familiar with the software development and using the command line interfaces. And final, you are generally familiar with the blockchains and smart contract platforms. Now we go to the tutorial objectives. By completing this tutorial, you will accomplish the following objectives. You can start peer blockchain nodes using the predefined accounts and generate key pairs for use as the network authority and create a custom chain specification file and launch the private to the blockchain network. And start the blockchain using predefined account. Before you generate keys to start on private software network, you can learn the fundamental principles using the predefined network specification called local and running under the predefined user accounts. This part of the tutorial simulates the private network by running two software nodes in a single local computer using predefined accounts that name Alice and Bob. Now we start the first blockchain node. To start the blockchain, we need to open the terminal. Here, and we change the root directory where you compile the Subtrino template. Subtrino template. Okay. Now you purge all train data by running the following commands. In the command prompt, you confirm the operation. I just word to remove, and you type Y to confirm that you want to remove the train data. Now we start the local blockchain node using the Alice account by running the following command. Here you can review some command line options. Yeah. You can see the base path. Base path here. It specifies the directory for storing all the data related to this train. Yeah, TMP RS. And you see the train local specifies the train specification to use. Valid predefined train specifications include local development and staging. Train local A. This line. And you see the RS adds the predefined keys for RS account to the node key store. With this setting, the RS account is used for the block production and finalization. And now you can see the port 30333. It specifies support to listen on the peer-to-peer traffic. Because this tutorial uses two nodes running to the same physical computer to simulate a network, you must explicitly specify the different ports for at least one account. You see the WS port 9945. It specifies the port to listen the incoming WebSocket traffic. The default port is 9944. This tutorial uses the custom WebSocket port number 9945 and RPC port 99333 specifies the port listen to the incoming RPC traffic. The default port is 9933. And now you can see the node keys here. Specifies the ED25519 secret key used for the peer-to-peer networking. You should only use this option for development and testing. Next line is telemetry URL. Specifies where to send the telemetry data. For this tutorial, you can send the telemetry data to the server hosted by pirating that is available for anyone to use. And the last one, you can see the validator specifies that this node participates in the block production and finalization for the network. For more information about the command line options that are available for the node template. See the usage by running the following command. I will open the new terminal. Copy this. Okay, you can see all the command for this node. It's have a line for describe the command. Okay, now you can review the node messages displayed. If the node starts successfully, the terminal displays messages describing network operations. For example, you should see output similar to this. Yeah. And in particular, you should note the following messages in output. In this slide, the initializing Genesis block state with a state and hash header hash. It identifies the initial or Genesis block that node is using. When you start the next node, verify that these values are the same. No, it's the same value. And you can see the local node identity is 1 hash per here. Local node identity, yes, specifies a string that uniquely identifies this node. This string is determined by the node key that was built to start the node using the Alice account. You use this string to identify the node to connect to when you start the second node. You can use this for the connect with other node. And you can see the lead time with the finalized and the ideal with the 0 periods. It indicates that there are no other nodes in the network and that no blocks are being produced. Another node must join the network before blocks can start to be produced. Now you can interact with the front end to see information about the node. You can see a lot of information about the node operations by watching the output in the producers in your terminal. You can also view information about node operations by using web browser to access the Papillon.js practical user interface. You can open this link. Now you can see the local node have 1 block, and the same browsers have block features that prevent the connecting a local node. If you have a trouble connecting to a local node, see if you have ad blocking enabled and disable it as needed. If your browser prevents connections to the local node, try using another browser like Chromium and downloading the hosting. Okay, you can go to this and go to the custom node. Find the development list of the network variables. Okay, you can verify the custom endpoints. You set your local host and the port number you specify for incoming WebSocket traffic. And you can use a single instance of Packet.js application to connect the different networks, nodes, and endpoints. Okay, if you don't have a port 9945, because in the basic custom you have a 9944 and you can change this and you add that. Now we can add the second node to the blockchain network. Now that the node you started using the Alice account keys is running, you can add another node to the network using the Bob account because you are joining the network that already running. You can use the running node identify the network for the new node to join. The commands are similar to the ones you can use before, but with a few important differences. Now I will open the new terminal. Look it. Okay, and now we go to the node template folder and search all train data by running the following command. Oh, we did not add this. Okay, and you can start the second blockchain node using the Bob account by running the following command. Okay, now Bob node is running. Note that the following differences between the command and the previous one. Because two nodes are running on the same physical computer, you must specify different values to the base ports, WS port and RPC port options. As you can see, if the first command is Alice, now it's Bob. And you can see it's Bob and it's the different port, WS port and the RPC port. You can compare it and go to previous command. 99, 45, 99, 33, Alice, here. Now this is 9946 and RPC port is 9934. Now you can see the boost nodes here. Yeah. and root node option and specifies a single root node. The node started by Alice. You can see some keys here. Now it's the same as here. The local node identity. You can compare it. Yeah, I will go to compare it. You can see it's similar. So you connect to the Alice node, and the boost node option specifies following information. You can see IP4 indicates the IP address for the node uses the IPv4 format, and you can see the IP address specify the IP address for the running node. In this case, the address for the local host. You can see the TCP here, and it specifies the TCP and the protocol used for peer-to-peer communication, and the port 30333 is specified port number used peer-to-peer communication. In this case, the port number for TCP traffic. You can see the hash code. This identifies the running node to communicate with it. For this network, in this case, the identifier for the node started using the Alice account. And now you can see some information about from the terminal. Open it. Yeah. Here you can see one pair here. There is one pair. They are produce some blocks, and the block number is increase by the time. Okay. And now you can open the Polkadot block export, and now it's not a zero block. Block is increased at the time. Yeah. By the two block, Bob and Alice. Now this video will introduce the local node, and the next video you can create your local node template. And see you in the next time. I will show you